Hi, welcome back again to my channel. For today's video, I'm going to make a tutorial for this chapter, which is chapter 6, the network layer. The network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses for basic processes. Addressing end devices must be configured with a unique IP address for identification on the network. Encapsulation, the network layer encapsulates the protocol data unit (PDU) from the transport layer into a packet. The encapsulation process adds IP header information such as the IP address of the source sending and destination receiving host. Routing, the network layer provides services to direct packets to a destination host on another network. To travel the other networks, the packet must be processed by a router. The role of the router is to select the best path and direct packets towards the destination host in a process known as routing. A packet may cross many intermediary devices before reaching the destination host. Each router a packet crosses to reach the destination host is called a hop. The encapsulation, when the packet arrives at the network layer of the destination host, the host checks the IP header of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. After the packet is encapsulated by the network layer, the resulting layer for PDU is passed up to the appropriate service at the transport layer. Unlike the transport layer, OSI layer 4, which manages the data transport between the process running on each host, the network layer protocols specify the packet structure and processing used to carry the data from one host to another host. Operating without regard to the data carried in each packet allows the network layer to carry packets for multiple types of communications between multiple hosts. Network layer protocols. There are several network layer protocols in existence. However, as shown in the figure, there are only two network layer protocols that are commonly implemented. These two is Internet Protocol version 4 or IPv4. The second one is Internet Protocol version 6 or IPv6. Encapsulating IP. IP encapsulates the transport layer segment or another data by adding an IP header. This header is used to deliver the packet to the destination host. The IP header remains the same from the time the packet leaves the source host until it arrives at the destination host. Figure 1 shows the process to create a transport layer, and Figure 2 illustrates how the transport layer PDU is then encapsulated by the network layer PDU to create an IP packet. The process of encapsulating data layer by layer enables services at the different layers to develop and scale without affecting the other layers. This means the transport layer segments can be readily packaged by IPv4 or IPv6 or by any new protocol that might be developed in the future. Routers can implement these different network layer protocols to operate concurrently over a network. The routing performed by these intermediate devices only considers the contents of the network layer packet header. In all cases, the data portion of the packet that is the encapsulated transport layer PDU, remains unchanged during the network layer processes. Characteristics of IP was designed as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected systems of network. The protocol is not designed to track and manage the flow of packets. These functions, if required, are performed by other protocols at other layer, primarily TCP layer. Let's move to the activity. We have here a IP characteristics. Read instruction first. Read each IP characteristics, then click connections. Connectionless, best effort, or media independent to indicate its delivery method. The first one that we have is a packet delivery is not guaranteed. It's best effort. No contact is made with the destination host before sending a packet, so it's connectionless. So does not guarantee that the packet will be delivered fully with error. So its best effort will send the packet even if the destination host is not able to receive it. So it's media independent. It's connectionless. So fiber optics, cabling, satellites, and wireless can all be used to route the same packet. So it should be media independent. So we'll adjust the size of the packet sent depending on what type of network access will be used. So congratulations, you have matched the IP characteristics to their delivery method. So that's all for today's video. So I hope you learn and understand it. So thank you for watching.